Hello guys, this is Amar Hatti, your CAD CAM teacher. Till now we are into your third unit, that is finite element analysis. As we know, we have a very less amount of time to complete all your syllabus. So what we do is, along with the learning your finite element analysis, we'll go for your fourth unit also, that is computer aided manufacturing. So today or every day I'm going to upload some two videos of your third unit and one video of fourth unit. Okay, well, we have less amount of time, you have to do quite hard work. Okay, so we'll start your fourth unit, that is computer aided manufacturing. Okay, so we are dealing with computer aided design and computer aided manufacturing. As the definition, computer aided design is with the aid of computer, with the aid of something, we are designing the object. Okay, that is computer aided designing. In the same sense, we have computer aided manufacturing. With the aid of computer, we are manufacturing the object after the design. So why computer? Well, till now, being a mechanical engineer, we are using any conventional or traditional machines. Okay, with just sketches and boards, we are having the design. Well, that is replaced by computer aided design. Okay, so as time changes, as modern era arises, we have the evolution, right? We have the new more discoveries, right? So with the aid of computer also, with the help of computer also, we are going to manufacture our object after the design. Okay, so computer aided manufacturing defines, with the aid of computer, we are going to manufacture the object. Okay, so that is about your computer aided manufacturing. Well, if you are studying CAM, your fourth unit, then you must know what we are going to study in your fourth unit. Well, in this one, we are going for your computer aided manufacturing, the simple introduction parts. What are the different coordinate systems? And here we have the topics and the working principles of NC and CNC machines, some different turning centers, milling machines. What are the steps for developing the CNC part programming, tool and geometric compensations, subroutine and do loop using Canada cycles. These are the theoretical parts. Okay, along with that, we are going to study what are the different machine NC machine tools, what are the different CNC machine tools, what are their advantages, applications, limitations, all those things. Okay, but the main important part of your fourth unit is the part programming. Well, we know that the computer numerically controlled or numerically controlled machines works by using part programming fed to it. Okay, we need to feed the part programming to it to produce the object, right? So we need to study part programming. So main importantly, your fourth unit deals with the part programming. Okay, that may be the simple lathe operations like milling, drilling operations. We are going to learn the part programming in this one. That may be the manual part programming or for turning centers and machining centers. Okay, so we'll go for the introduction part. Well, your first unit or fourth unit, the first part of your fourth unit is going to deal with your simple numerically controlled machine tools. Before going to the computer numerically controlled machine tools, we must know what is or what are numerically controlled machine tools. Okay, so how I am going to define numerically controlled machine tools? Well, these are the machine tools of which various functions are controlled by a program fed to it. Okay, a program fed to it. What I said, whatever the operation of numerically controlled or computer numerically controlled, we need a program. Okay, a systematic or a set of instructions or a statements we need to write down and we need to feed it to the machine tools, and it is going to perform the operation as per the statements or instructions what we are given. Okay, so these are the machine tools of which various functions are controlled by program fed to it without the human operator. So the NC program consists of a set of instruction or statements for controlling the motion of the drives of the machine tool, for the motion controls of the drives of the machine tool. So what are the functions? Well, a question arises in your mind, what are the functions which are controlled by the program what we written, and we are going to find it to NC machine tools. Like if you want to start the machine tool, if you want to stop the machine tool, you have to write the part program. For controlling the spindle speed, you have to write the part program. Well, the part programming consists have the instructions like what are the different positions of the tools or the desired locations, and how to guide it along the desired part. We have to write it in a part programming. And if I want to change the feed rate, spindle speed, or changing the tools, I need to write it in a part programming. So the part programming contains this function. Okay, so this is about introduction of NC machine tool. So next comes what are the different elements of NC machine tools? What are the different elements of NC machine tools? Well, if we see, we have a basic elements of NC machine tools as initially we must have a part programming or a part drawing and part program. Part drawing and part program. Next, program tape. Third one, machine control unit, and finally the machine tool. Okay, first part drawing and part program, second program tape, third machine control unit, and the fourth one is machine tool. Okay, so you must know what is part drawing and part program. So using the part drawing and the cutting process parameters, the part program is written. Okay, so by using computer aided drawing, we need to have the part drawing, and by using the cutting process parameters also, we need to write down the part program. Okay, so the part program, as I already said, is a set of step-by-step instructions to the machine tool for carrying out the operation. Okay, it is a step-by-step instructions to carry out the operations. So what these step-by-step instructions involve or include? Well, instruction for position of a machine tool spindle with respect to work table. Well, we have machine tool spindle and a work table. We need the position to keep the machine tool spindle with respect to work table. So this part program has this instruction, or this instruction it is going to have, and it has the instruction for cutting operation. So which different types of the cutting operations need to be done to get a desired object, it has this instruction. And what are the different some more instructions like selection of spindle speeds, selection of cutting tools, selection of different coolants. This information or instruction this part program is going to have. Okay, so you may ask me what are the different methods used for part programming in simple numerically controlled machines. Okay, so initially we are talking about the numerical control. This is the initial one. Okay, so we can fed the program to the numerically controlled machine by using manually also, and also by using computer aided part programming. So we have two different methods by using we can fed the part programming to NC machine. The initially manual part programming, and the second one is computer aided part program. So a number of language, a different number of languages are available for part programming. Okay, but the most commonly used is computer aided part programming. Okay, so this is about part drawing and part programming. So next basic element is part program tape. Okay, program tape. So the part program is going to enter on the part program tape. So on program tape we are going to enter the part program. So this tape is a long wound roll of 1 inch width. Well, you can consider it is a long wound roll which has 1 inch width, and the program is entered on the tape in the form of punched holes. Okay, on this long wound roll which has 1 inch width, the program is entered on this tape in the form of punched holes, and the holes are punched with the help of punching machine. Well, You may seen the computer numerically controlled machines, you may seen the vertical milling centers. You may ask me, sir, we haven't seen any wound roll while we are going to, while you are saying we are entering the part programming in the form of punched holes on this wound roll, but we haven't seen any wound roll. So my dear, what I am talking is, well, I'm coming from the initial one, the conventional one. When the numerically controlled machine has invented, the part program need to be fed on the wound roll by using the punched holes. Okay, so, but the tape medium is now absolute, and nowadays the program is input through a magnetic cassettes, simple CDs or any floppy disks. We are going to fed it. Well, in computer numerically controlled, we have a graphics input, we have a memory, we don't need even the CDs or compact disks. Okay, so this is about program tape. Next comes is your machine control unit. Well, the very important part in numerically controlled machine, the machine control unit. Well, we have two parts of the MCU, that is machine control unit. The first one is tape reader and the second one is controller. Well, as I said, we have the program tape. In machine control unit, we have tape reader. Okay, so the program tape is read by this tape reader, and the controller takes input from the tape reader and actuates the drive and the tools of the machine tools. Okay, so the controller, we have a second part of the machine control unit, is going to take the input from this tape reader and starts or actuates the drives and the tools of the machine tool. Simple one. Okay, simple one. That is your machine tool. Well, the final part is your machine tool. The basic element, the final basic element is your machine tool. A simple machine tool is operated by the controller of the machine control unit. Well, we have a control unit in your machine control unit, and machine tool is going to operate as per the instruction given by the machine control unit. In NC machine tools, one or more of the different automatic functions may be used, like starting and stoppage of the machine tool spindles, like controlling the spindle speeds. As I already said, if I want to control the feed rate, if I want to change the tools, if I want to position the tool tip at the desired location and guide it along desired path by automatic control by using slide motions, I need the machine tools. Okay, the machine tool is going to perform the operations like this: starting, stopping, controlling the spindle speeds, controlling the feed rate, speed, and changing the tools. Okay, now you may ask me, sir, what are the different machine tools? What are the main or different main components of the machine tools? Well, you can have a work table, machine tool spindles, all the drive units, and even this machine control unit. And some machines have the feedback mechanisms. Okay, so that feedback mechanism also comes in machine tools. If we have magnetic box or manual control units, that is also comes in your machine tool. Okay, so this is about your basic elements of the numerically controlled machine tools. Well, a question comes to your mind: what are the different types of numerically controlled machines? So classification of numerically controlled machines. Well, numerically controlled machines are divided according to three things. Well, according to first one, according to control loop feedback system. Control loop feedback system, we have two types of the numerically controlled machine. One is open loop type numerically controlled machines, and the second one is closed loop type numerically controlled machines. Well, the second type is divided according to type of tool motion. Type of tool motion, we have two types. One is finite positioning control numerically controlled machine. Second one is continuous path control numerically controlled machines. In those things, we have some different numerically controlled machines. Okay, well, the final one is according to programming method. For by using different programming method, we have two different CNC machine systems. One is absolute programming numerically controlled machine system, and the second one is incremental programming numerically controlled machine system. Well, we'll go to one by one. The first one is according to control loop feedback system. Well, what is control loop feedback system? Well, the name itself indicates it is divided based on the control loop feedback system. Okay. So you can see the first one, first type in this one we have the open loop type numerically controlled machine system. What is open loop type? Well, you can see here you have input signal which is given to or which is fed to tape reader. Well, the tape reader is going to give it to the amplifier, and amplifier translate the data what the program what is given by the tape reader, and it is going to translate it into machining language and give it to the drive motor. Okay, drive motor sends the signals or whatever the program instructions given to it to the gear box, and machine tool will have the slide displacement. Okay, while the input has given the side displacement, and it is sent all the data to the further or superior next to one. Okay, but what is control loop feedback system? That is open loop feedback system. Well, this open loop control system do not have a feedback mechanism. Okay, do not have a feedback mechanism. So if something went wrong by giving an input signal, it is going to manufacture the same thing what you are given. Okay, so it is not going to give you some feedback like the design what you are given is wrong, the dimensions what you are given is wrong. It is not going to give you the feedback. Okay, so the open loop machine tools controls have only motion controls but do not have any provision for a feedback. Okay, it has only motion control. It is not going to have any provision for a feedback mechanism. Okay, which need to be, if I want to compare it, if I want to be improve the dimensions or improve the design, it needs to be compared with the input for better control and correction of the drive system. Okay, drive system, it doesn't have any feedback mechanism. That's why it is called as open loop type of numerically controlled machine system. So it may be a limitation, right? It may be a limitation. So if I want to overcome that limitations, we have a different type of numerically controlled machine. Well, that is called as closed loop type of numerically controlled machine. Closed loop of numerically controlled machine. Well, you can see here we have an input signal. Well, it is read by the tape reader. Well, we have a new disk here, that is comparator. Okay, then it is same the amplifier which is given to the digital to analog converter, then drive motor, gearbox, well finally the machine tool which has a slide displacement. Okay, along with that we have a measuring unit which is connected by the machine tool, and it gives the signals to the comparator. What is this? This is the closed loop type of numerically control. Well, it is a closed loop. Well, it has a feedback mechanism. So closed loop control system have a feedback mechanism. Closed loop machine tool controls have the motion control along with a provision of a feedback, which can be used for accurately controlling the drive system by comparing it with the input information until the required or desired position is achieved. That is why we are using the comparator here. Okay, if something went wrong in the design, while the machine tool is going to give the feedback system to the measuring unit, and measuring unit will send the signals to the comparator. Well, if I have any model which is already designed or which is already manufactured, we are just going to compare it with the input what we are given. If something is wrong, we are just going to correct it. So if it is have a feedback mechanism along with the motion control, then it is called as closed loop type of numerically controlled machine tools. Okay, so this is the first one. While your second one is divided according to the type of tool motion control. Well, we have two types of CNC and NC machines according to type of tool motions. The first one is finite positioning control NC machine, And the second one is continuous path control NC machine. Well, wait a minute. So first one is your finite positioning control NC machine. Okay. Well, the name itself indicates we have a finite positioning. Finite in the sense we have some dimensions we can move to the point or the tool from one position to another position. Well, you can see here some more downside. We have two types of the finite positioning control NC machine systems. One is point to point numerically controlled machine, and the second one is straight cut numerically controlled machines. So what is point to points CNC or NC machine? Well, in this one, the movement of the cutting tool from one position to another predefined position is important, while the path along which this tool moves is not necessarily relevant. Okay, not necessarily relevant. We are only we are only or it is only important that cutting tool has the movement from one position to another position, while whatever the path it is going to follow to move from one position to another is not important. Okay, the only important part is one position and another predefined position. Okay, so that is important. If I am having the NC machine and I programmed to it from one position to another where the path what it follows doesn't matter, then it is called as point to point CNC machines. Okay, so while it is drilling a hole, we can have the example of NC drilling machines, punching machines, or spot welding machines. Okay, and also this type of control mode is least expensive of all the modes. Simple one. Okay, just one position and the final position. Okay, so next comes is your straight cut NC machines. Straight cut NC machines. So you can see here, you can see the figure what it indicates. While the straight cut or straight line control mode is in the extension of the point to point control mode with the provision of straight line cut or a machining. Where in the point to point CNC machine we cannot cut, we cannot have the straight line or cut of the machining, but we in straight cut CNC machine we have a provision for that one. Okay, so this straight line cut is obtained by controlling the movement of the tool with controlled feed rate in one of the axis of the one of the axis direction at a time. One of the axis direction at a time. Well, you can see here we have a figure. Well, that is a lathe machine. A job is connected to the spindle and we have a tool. Okay, in any of the one direction in X axis the tool is have the movement. Okay, so example of this one are the simple face millings, pocket milling, or any step turning operation. It has the examples. Okay, so next comes is your continuous path control CNC machine. Continuous path, that is the second part. Okay, well, the name itself indicates the continuous path control system is used for continuous, simultaneous, and coordinated motion of cutting tool and workpiece along different contoured profiles and curved surfaces. If we have a curved surfaces, if we have any contoured surfaces, we are going to use the continuous path control system CNC NC machine control units. Okay, well, it is also called as contoured path control systems. Okay, so in this control mode, most of the slide motions are controlled simultaneously. Okay, simultaneously, so that their relative positions pass through the desired contoured path of the final shape of the required product. Final shape of the required product. Well, in this continuous path control systems, we have 4 different types of NC machine systems. Well, the first one is two axis countering position, okay, or you can just call it as two axis countering, okay, two axis countering. Well, in a simple sense, by seeing the figure itself, you can say that in this control mode, tool is only controlled simultaneously in only two axes, x and y, as shown it in the figure, okay. So the tool only can have the movement in x or y, x and y, okay, not x or y, x and y. Then that numerically controlled machine system is called as two axis contouring, okay. Next is your two and half axis contouring. Well, what is this half? What is this half? Well, in this two and half axis contouring control mode, the plane of the machining is inclined, quite inclined to the plane of the motion of the tool, okay. well well, let me repeat it again. The plane of the machining, well, we have a machining plane that is quite inclined to the plane of the machine motion tool, okay. Plane of the motion of the tool, well, you can see it in the figure. We have a tool path which is actually the curved one. The control plane or a machining plane is quite inclined. If that is inclined, the machining plane of machining is inclined to the plane of motion of the tool, then that is called as two and half axis contouring, okay. So the third one is three axis countering position control. Simple one. Simple one. Well, the tool is simultaneously controlled in all the three axes. If it is controlled in all the three axes, that is called as three axis contouring position control. Well, the final one is your multi axis contouring. Multi axis contouring. What is multi axis contouring? Well, in this control mode, unlike all the others like 2, 2.5 and 3, the tool orientation can be changed with the tool motion. The tool orientation can be changed with the tool motion. Like for example, a 6-axis machine tool is capable of moving the tool in all the primary axes and also can rotate about each primary axis at the same time. So I can move my tool in all the direction, and also I can have a rotation about each primary axis. If that is called as if that is allowed, then that is called as multi-axis contouring, okay. So this is about according to the tool path motion. So finally, your numerically controlled machines are divided according to the programming method. Well, in this one, we have two types of machine systems. One is absolute programming numerically controlled machine system, and the second one is incremental programming numerically controlled machine system. Well, what is absolute programming numerically controlled machine system? Well, you can see in the figure, we have a workpiece. We have three holes, P1, P2 and P3, okay. Well, P1, the center of P1 is at some distance away from the origin. P2 is same, some distance away, and P3 is also some distance away from the origin in X and Y direction. We have mentioned it in a Cartesian coordinate system. So in this Cartesian coordinate geometric system, using absolute measurement, each point is always specified using same zero established for a given coordinate system. Okay, have you understand? In Cartesian coordinate system, if I am representing my object, each point is always specified using same zero establishment, okay, same zero establishment. Let's consider the point P1. Well, you can see it in the right side in the boxes. Well, we have a point P1. It has incremental coordinate x's. X in x direction it is 10 mm away from the origin, and y it is 10 mm away from the origin. Let's consider the point P2. Well, we need to consider the dimension of this P2 from the origin itself, okay. So that P2 is 25 mm and 20 mm away from the origin in x and y direction respectively, okay. So we need to consider that point from the origin, and same for P3, 50 and 33 mm, 30 mm away from the origin in x and y direction. So if you are considering each point which is always specified by using the same zero establishment, then that type of programming method is called as absolute programming system. Absolute programming system. So next, a quite change is your incremental programming system. What is incremental programming system? In Cartesian coordinate system, using incremental measurement, each point, whatever the point it is specified using the reference of the preceding point position. Reference of the preceding point position. We don't need to define the point by using the same origin, but we need to define the position by using the preceding point position. Well, you can see here, same here we have P1, P2 and P3. Okay, we have P1, P2, P3. Well, in the right side you can see here P1 is 10 mm and 10 mm away from origin in X and Y, but it is an incremental programming system. And P2 we need to P2 we need to take the distance it is away from the last preceding point. Well, the last preceding point is P1. Okay, so that is 15 mm and 10 mm away from the last preceding point in X and Y direction. And P3 25 mm and 10 mm away from the last preceding point P2 in X and Y direction respectively. So these are the type of numerically controlled machines according to different conditions. Okay, so next comes is your CNC machines. Well, we don't have much difference between the numerically controlled and CNC machines. Almost all the same things. Okay, same things. Only here, only there, all the program which is fed to it is controlled by the numerically it is controlled. But in CNC, by using computer, we are going to control the machines. It is also here also it is controlled by the control loops feedback system. According to type of tool motion, according to program methods, we are going to have different CNC machines. Okay, so I think this is enough for this class. So in next class we are directly going for the your CNC part programming. Okay, well, the basics of the CNC part programming we are going to study in the next class. Okay, till then, have a happy day. Bye.